Good morning. We are set at September 15th, which is our deadline for signing up for dual credit, if that is what you're interested in doing. Please make sure that you are doing that today if you have not already done so, and that is something that you would like to do. All the information is on here. This is a hard deadline. There will be no late registration. So if you want to do that, you need to get that completed today. On our schedule for today, we have polynomial functions of higher degree. There is a video here attached in the instructional support. I'm also going to do a couple questions on this video that I know that people will struggle with. If you're looking at what is today, today is also our live lesson, which we will go over some other things that pertain to this assignment. Would love to see more people join. If you do have questions, you can send them to me on email and I will respond as quickly as possible. But if you would like to join in that live lesson, that would be great. Would love to see you. So right now I'm going to go ahead and go over and do an example similar to one that you will see on your homework. So I'm going to share a different screen. So a lot of what you'll be doing in this assignment will be using Desmos or a graphing calculator. And so you're going to be matching graphs. You're going to be finding zeros. If you're using Desmos, Desmos is wonderful at finding zeros. Really, you just have to click on where it crosses the x-axis. Graphing calculator is a little more work, but you can do that on there as well. So if you're looking at this question, this one is giving you the zeros. So it wants the polynomial functions. You have to work backwards. To be able to do this, you would take x minus 3 times, so you have to take x minus each one of your roots. What you have to be careful with is when you have these roots that have two pieces, you're going to have to distribute the negative through. So we have x minus and then my root, and then x minus my last root. So what we're going to do is we're going to have x minus 3. I'm going to go ahead and do that distribution. So I'm going to have x minus 2 minus the square root of 7, and then x minus 2 plus the square root of 7. Now, my suggestion is to always multiply the two pieces that have the square root first. So I'm going to take x times x, that's going to give me x squared, and then minus 2x, then plus x square root of 7. Go ahead and multiply the next one. So I'd have negative 2x plus 4, and then minus 2 square root of 7. I'm going to run out of room a little bit, so I'm going to go below. I would have negative x square root of 7, and then plus 2 square root of 7, and the last piece would be minus 7. What you'll notice here is we have a positive x squared of 7 and a negative x squared of 7. Those are going to cancel. We also have a 2 square root of 7 and a negative 2 square root of 7. Well, these are really conjugates, and when you have conjugates, that will get rid of those square roots. What actually makes this a little nicer. So when we combine this, we would have x squared minus 4x, and then I'm going to have a minus 3. Now, we also still have to multiply that by the x plus 3, or sorry, the x minus 3. So distribute that. So this is going to give me a cubic. If I have 3 solutions, I have a cubic. Then I have minus 4x squared minus 3x. Doing the next one, I have a negative 3x squared, and then I have a positive 12x and a positive 9. Combining our like terms, we would have x cubed minus 7x squared plus 9x plus 9. And that would be my solution. So again, make sure that you're careful distributing the negatives. After you've distributed, multiply the parts with the square roots first. And this works with imaginary as well. You always want to multiply those first to kind of get rid of either the square root or the imaginary part. Then take that solution, multiply by your other root, the x minus 3, and then combine your like terms. Another question, it's kind of similar to what we just did. It says find a polynomial function with a leading coefficient of 1 or -1 with the given zeros, multiplicities, and degrees. So multiplicities, what you have to mean, it's a root that appears more than once. So in this case, when it says a multiplicity of 2, it appears twice. So if you have a 0 of 1 with a multiplicity of 2, that's going to tell me that I have x minus 1 squared. The next one says I have a 0 of 2 with a multiplicity of 2. That's going to be x minus 2 squared. It says I have a degree of 4. Well, if you think, I didn't write that down right, it's going to be x minus 2 squared. If you were to multiply that out, you would get x squared times x squared, which is going to give you the degree of 4. So we can check those conditions off. It says it falls from left to right. Falls to the left and then falls to the right. So falls to the left. That falls to the right. This is falls to the left and falls to the right, means it's opening down. That means that you have to have a negative leading coefficient. So that means that both ends are going the same direction. So that also means that we probably need to multiply by a -1 out here. Now, this is a polynomial function, but they will want you to multiply that all out. And that's the same process that you did above. So falls to the left, falls to the right, both ends are going down. Degree of 4, if you multiply it out, your highest exponent would be 4. Remember that multiplicity is a root that appears more than once. In this case, they're going to appear twice. So be careful as you go through that. If you have other questions, just send me an email or join us in our live session. Have a great day.